Hello everyone, welcome to Snow Bundle channel, and I'll be discussing on a series of videos on warehouse. And the contents I'll be covering in the series of videos are the warehouse overview, the warehouse cost and their size overview, and we will discuss on how to create a warehouse by using UI method and also using the SQL based method, and what is the limitation by creating a warehouse using the UI based method. And also we will discuss on the warehouse monitoring object in the Snowflake inbound database. Also, I will discuss on the parameter which can be set on the warehouse level and which all functions to be used for seeing the warehouse parameters which has been set. Then we will discuss on ways to track the warehouse cost using the resource monitors and alert and notifications, and we will create one dashboard for warehouse cost and credit analysis. And in the last, we will create one procedure for automating the warehouse size, and we will schedule it so that the warehouse size will be adjusted for a specific period of days. Then it will be sent back to the original state. That I'll be discussing on the last series of the video. And coming to the first point, what is warehouse? The warehouse is a compute part of the Snowflake. We know that the compute part in the warehouse, which includes the CPU, memory, and temporary storage, these kind of resources are associated with the warehouse, and the warehouse is mainly used for running the queries. We know that the warehouse cost or the credits will be consumed when we will run the select statement or select queries, and when we will do the data manipulation DML operation by using the statements like insert, update, delete, and merge statements. For data loading and unloading, the warehouse will be consuming the credits, or the warehouse will come into the picture. And for some of the operations where we will run the metadata operation, and for DDL operation, the warehouse won't come into the picture. And also for show, describe functions or parameter functions, the warehouse is not required. Also for running the control functions as well, the warehouse is not required. And to drill down further, the warehouse cost is also depending on the type of account we have. Whether we have a standard account, the pricing will be different, and for enterprise edition, business critical edition, and virtual private Snowflake edition, so for all these editions the cost will be different. As the standard goes up or the edition goes up, the price will be increasing. As we will have a premium feature in the enterprise plus editions, so the cost will be more in those editions compared to the standard. And when it comes to the pricing section, there are two types of pricing. One is on demand pricing and capacity pricing. So on demand pricing is a kind of pricing where the customer will have a contract of 3 months with the Snowflake, where he will be utilizing the warehouse, and after that, like maybe 2 months, it will be kept in idle, and again there is a demand will come, and the warehouse needs to be run, or the queries needs to be run from the Snowflake environment. So that time, whenever the demand will create, so that time the Snowflake needs to be used. And when it comes to the second category, which is the capacity based pricing, where the customer or the vendor will have a contract with the Snowflake for a longer period of time. To give an example, consider you have made a contract with the Snowflake for complete 1 year. You'll say that you'll be using Snowflake for the complete 1 year, and for that you'll be paying a certain amount in the initial period itself, and you are liable to pay for the 1 year of the cost associated, which is generated from the Snowflake compute, storage, and data transfer activities. So whatever the cost will be generated from all of these activities, so that you are liable to pay for the complete 1 year. So this is a capacity. So here you have fixed the capacity of the 1 year. So on demand comes into the picture when there is a demand is created for a period of 1 month or 1 day or 15 days. So on that demand, you will be utilizing the Snowflake. And to check the pricing, so let us go to the pricing window. If we see here, the standard edition will cost $2 per credit, and for enterprise it will cost for $3 per credit. and for business it is double of the standard, and for virtual private Snowflake, so for that they haven't disclosed how much of credit, but usually it will be more than 4. Take an example of extra small warehouse. If we run the extra small warehouse for 1 hour, and for that the billing is 1 credits, and the cost associated for that 1 hour period is $2 if we are using the standard edition, and for it will be $3 for the enterprise edition. And as the warehouse size will increase, the per hour credit cost will be different. And when you have a capacity based Snowflake, so for that this price will be negotiable, where in the contract these prices will be usually reduced. To give an example, for the business critical edition they can go up to 3.5 or 3 if the longer duration of the contract has been made. It won't be for all the time, so it will be for only for the on demand based Snowflake usage. Here is an example for the storage. For the on-demand storage, it will be $40 per TB per month, and for the capacity storage, you can see that it is lesser than $17 per TB per month for this region. So this is an example for AWS vs East North Virginia region. For that, $40 will be costed for TB. So that is about tracing. We will create one warehouse using the UI based method, and now we will discuss on creating a warehouse using the Snowflake UI based method, which is from the Snowsight. Click on the plus warehouse button to create a warehouse, and I'll be creating a developer warehouse and giving a name as dev warehouse and giving a comment as it is a developer warehouse. As you can see, the type of warehouse is standard, and there is one more option called Snowpark optimized, and by default it comes with the standard type. And what is the difference between the standard and Snowpark optimized is standard type will be used mainly for the data warehousing purpose or for the data analytics purpose, where the users will be running the queries inside the Snowflake data warehouse, and they won't be using any complex queries which will consume the large memory. Snowpark optimized warehouse will be used when the input data is of high size and which needs to be processed in a high memory space. Usually the ML problems will take a large amount of input data for training the model. So for that, Snowpark optimized warehouse will be used. As you can see, it starts with a medium warehouse itself, and there is no warehouse with the extra small and the small warehouse type. As you can see, the medium warehouse is of 6 credits per hour for the Snowpark optimized, and for the standard, if you see, the medium warehouse is of 4 credits per hour. It means that operating with the Snowpark optimized warehouse per hour will cost more than a standard type. And to explore more on this, the sizes of the warehouse, here you can see by using the extra small warehouse, it will take 1 credit per hour. For smaller it will double, for medium it will double of the small. Here the compute nodes from the extra small to small will be double of this. So larger the warehouse, so larger the temporary memory, and it will have more cache in it, and it will store more of input data to process and to give the result. Ideally, it is good to experiment with the smaller warehouse, then start increasing the warehouse based on the performance. This autorism will make the warehouse to enable or starts running when the new query is fed into the Snowflake. So when the new query starts executing, so that warehouse will start executing the query, else it will be in a suspended mode. So auto suspend modes, what it will do is when the warehouse will be in a inactivity for a certain period of time, which is mentioned here, it is been mentioned that 5 minutes of inactivity by default. If the warehouse is not executing any queries since 5 minutes, then it will automatically go into suspended mode, by which we don't need to externally make the warehouse in a suspended mode. If this auto resume mode is not enabled, To start executing the query, we have to go to the warehouse and resume it, then only the queries will start executing. And how we have to come up with a number for a auto suspend mode is based on the use cases. Usually for the developers and tester, where they don't need much of warehouse cache into their work, so for them keeping the auto suspend mode with a lesser value makes sense. As I'm talking, the warehouse cache isn't been linked with the auto suspend mode. So what is warehouse cache? Warehouse cache is the amount of data which is being held by the warehouse by executing the queries. When the warehouse will suspend, so that time whatever the cache it holds, it will evaporate. So by using the warehouse cache, the subsequent queries will make a benefit of the scanned partition or the scanned data by the warehouse. Usually for the analyst and architect, where they will more of the time work in analyzing the data, for them there will be more of overlapping queries or overlapping data while analyzing the data. For them, keeping the auto suspended mode more than 2 minutes will make sense. However, setting the auto suspend mode to a value needs to be trialed for each of the role, then it needs to be finalized. And coming to the next option, multi-cluster warehouse. Multi-cluster warehouse is the option which will come in the enterprise plus higher edition. Here we have an option of choosing the minimum and the maximum number of clusters. So these clusters are nothing but compute nodes. Example, here I have chosen the medium warehouse. Consider it is having 4 nodes in that, and when the warehouse is started with the 2 clusters, then it will have 8 number of nodes started executing. So when this will be useful is when there are more number of concurrent queries are running by the user. So that time scaling the compute nodes horizontally makes sense, as there is no need of increasing the size of the warehouse. We don't need to increase the memory or we don't need to increase the compute size. Ideally, for each warehouses or the new warehouse, the default maximum concurrent queries is set to 8. If there are more number of concurrent queries, then the next cluster will be spinned up. Here we can see that scaling policy by default it came with the standard. When there are 8 concurrent queries are running, and if there are few more queries came into picture, so that time next cluster will be spinned up and the new queries will be taken by the next cluster. By setting up the economy mode, here we are optimizing the cost. Consider an example. There are 2 users and the first user is running the 6 queries and the second user is running the 8 queries parallelly. So the first cluster will take only the 8 concurrent queries, and the other rest of the queries will be in a queuing state. So when the next cluster will be triggered is after waiting for a 6 minutes of queuing time, still the first 8 queries are running, then the next cluster will be spinned up. But for the standard case, it won't wait for the queries to be queued. It immediately triggers the next cluster, so that users will utilize the new cluster for running the queries. And to talk on this query acceleration, the query acceleration will speed up the query scanning pattern so that it will give the result in a faster way. You know that this query won't come all the time. You won't be running these queries more of the time, but it will come in an ad hoc basis. Also, there are some of the queries where you wanted to use the filter, and wherever you use the filter or aggregate function, there you wanted to get the result in a faster way. By offloading some of the partitions to be scanned to some other compute nodes apart from the warehouse size which we defined for this warehouse. So here we have used the medium warehouse, and consider it is holded out of 30 partitions, so it is already scanning around 20 partitions. So rest of the 10 partitions you wanted to offload it to some other compute node. So that time this query acceleration factor will come into the factor. The scale factor defines up to how many times serverless nodes or the compute nodes which are apart from this warehouse needs to be utilized to fetch the result faster. If I set to factor of 2 means, here I am using the medium warehouse. Consider it is having 8 nodes in it. So by setting the acceleration with a factor of 2, it will have 16 nodes of compute which will be used for scanning the extra 10 partitions. And how do we identify that for which warehouse, for which queries this query acceleration is really helpful? For that, there are function associated with that, and also there is a one view called query acceleration eligible view in the Snowflake account usage schema. And to find which all queries in the history where use the query acceleration parameter where we have set it for the warehouse. So we don't initially get to know that we have to enable the query acceleration. So this comes with the history itself. So to understand which queries are using the query acceleration parameter, so for them we can run the query from the view called query acceleration eligible view from the account usage schema from the Snowflake inbound database. And by running this view, we will get to know list of the queries which are using this query acceleration parameter effectively. Consider there is a one query which we identified from the query acceleration view that it is using the query acceleration parameter effectively to get the result faster. For that, we have to run the system dollar estimate query acceleration function with a query ID which we fetched it from the query acceleration eligible view. So by which here it is giving a set of values in the JSON format. 1, 10, 2, 4, 8 are the scale factors. With the one scale factor, it is taking 171 seconds to fetch the result. If there is no scale factor or query acceleration are using, then it is taking 300 seconds to fetch the result. Consider for the medium warehouse there are 8 nodes as I have taken the previous example. By using the one scale factor, here in total we will be having 16 nodes. Here we can see by setting up the scale factor higher value than 1, it is taking less time in fetching the result. By default, it comes with the 8 scale factor. If you don't adjust it, then it is taking 120 seconds to fetch the result. It is ideally we need to do the trial and error to understand which warehouse will be utilizing the query acceleration and how oftenly and how many queries will be coming into the query acceleration eligible. By understanding the data for a 1 month and analyzing for a query acceleration parameter will give an idea for how much of scale factor we need to set it. And where do we find this query acceleration view? So for that I'll be going to Snowflake window. I'll be giving this as a cancel. Here if you go to data and search it for query acceleration, here you can see query acceleration eligible view in the account usage schema of the Snowflake inbound database. Also in the organization usage query acceleration history view is also present. Currently I haven't run the complex queries where it is not utilizing the query acceleration parameter. For that you will find that this view is empty in my case. Also for the running queries, how do we identify whether how much of partitions are offloaded for the query acceleration for the running queries? So that we can check with the query profile for the query ID from the query ID. Here I went to Snowflake documentation. We just search it for a query acceleration services, and in that this is the one example where they have taken into consideration by enabling the query acceleration in the query profile. This and there are two other values are also mentioned: partition scanned by services and the scans selected for acceleration. So out of total 876,000 plus partitions, the current warehouse is scanning around these partitions, out of which if there are any filters, and it will take out some partitions out of it, and the remaining partitions are dumped to query acceleration to get the selective number of filters which are used in this query. And also if you wanted to see how many partitions are scanned and how many bytes were scanned by the query acceleration and what is the upper limit of scale factor is being used, because when we set the scale factor as 8, it doesn't mean that it will use all the multiple of 8 compute nodes in extra to the warehouse size defined. It will start with a minimal, then it will start adding more into that when the number of partitions uploaded into the query acceleration will become more. So all these columns can be availed in the query history view from the Snowflake account usage schema, with which we can use this history for reducing or increasing the scale factor. And now we will discuss on how we can create the warehouse by using the SQL method. For that, I'll be going to worksheet showing all the parameters which we can define while creating a warehouse by using SQL method. Here we have to use the creator replace warehouse with the warehouse name, and the object properties are these are the object properties, and the tags will be useful when we wanted to filter or assign the warehouse or group the warehouse to particular department or particular tag, so that for data governance it will be helpful. It means that you wanted to group the set of warehouse into one group, and you wanted to keep an eye on those set of warehouses with a certain number of credits. For those cases it will be useful. And to discuss on this object properties, warehouse types, this we discussed standard, snowpark and optimized. And the warehouse size, these are the warehouse size which we can define, and the number of credits for each warehouse will get doubles as the warehouse size will increase. And these all things we discussed. And coming to this option, initially suspended is available only in the SQL based method. So when we create the warehouse using the UI based method, warehouse will start. However, the same is not case with the SQL method. Consider a case where you wanted to create a multiple number of warehouse and you are setting a warehouse inactivity or auto suspend mode of 5 minutes. So that time, if you create a warehouse using the UI based method, so that time, even though you are not using the warehouse for executing the SQL, the warehouse will start running and you will be charged for extra 5 minutes, in which case you haven't used the warehouse for running the queries. To mitigate that issue, you can use the SQL based warehouse creation method. Also, there is an option to suspend as well in the UI based method. You can use it. We don't need to externally depend on this initially suspended mode parameter. And to add the resource monitor, so this I'll be talking in the upcoming series of videos. Resource monitor are used for tracking the warehouse consumption credits for a predefined period of time. Here I've pasted one warehouse creation method using the SQL, and the warehouse name is dev warehouse, and the warehouse size is extra small. Minimum cluster count is 1, maximum is 2, and initially suspended equal to true, by which when the warehouse is created it won't be in a running mode, it will be in a suspended mode. And one more thing I forgot to mention is the resource monitor can be only used when there is an existing resource monitor for which we wanted to add the newly created warehouse into that group. So I'll be running this one. Since I'm already having the developer warehouse, so it just recreated. So I'll be just giving a different name for that. Okay, as you can see, it is in a suspended mode, dev1. So how do we identify whether it is in a suspended mode or what? So that we can check in the admin warehouses. Here you can see dev wh1 is in suspended mode, and I will show you with the UI based method as well. Just to dev warehouse, I have created dev warehouse _2. So let this be in standard mode and extra small, and advanced auto suspended mode is equal to 2 minutes. And I will just won't enable these two options and create a warehouse. Here you can see that dev warehouse 2 is in a started mode. It started consuming the credits even though I'm not using this warehouse. So for that I have to externally suspend this warehouse like this. Otherwise it will go in auto suspend mode after 2 minutes of inactivity, where I have defined for a auto suspended mode value. That's it for this video, and we will cover other topics in the next video. And in the next video I'll discuss on the warehouse monitoring object and the other warehouse function which we can use to know more about the warehouse utilization or the warehouse parameter which is being set. Thank you. Please subscribe to my channel and let me know in comments if you have any questions or if there is more clarification is needed on any of the concepts which I discussed.